Hello again. In this lecture, we're going to learn about factoring by grouping. Before we factor by grouping, though, we're going to do a problem that requires us to factor out the GCF. And this first one is kind of funky the way it's written, so it'll get us used to grouping. That's hopefully the goal, at least. So we have t times 8 minus m plus s times 8 minus m. Now, when we are looking for a GCF, we don't want to mess with this thing too much. We're going to look for a pattern, something that they already have in common, because these things are written as a product already for us. And remember, when we find the GCF, we do the prime factorization and we try to collect the prime numbers. Well, we have t times something very ugly, plus s times something actually kind of the same ugly thing, right? So that is the pattern we're searching for. They're both being multiplied by that same 8 minus m. So we can factor out that. I know it's weird because we're seeing it as a binomial, but this whole thing is being multiplied to each of these terms. So we can take it out and we'll keep it in parentheses. And what's left behind is the t here and the plus s. But we're going to have to keep in parentheses, just like when we factor out a GCF. Whatever's left behind, we'd say t plus s. And now we have a product, and we're done. So weird, I know, it takes a while to get used to. So let's see another one, just to be safe. We have 2x times 3x plus 4 minus 5 times 3x plus 4. And even when I'm reading it, you probably heard me say 3x plus 4 twice. That is our pattern. They both have that 3x plus 4. So we can factor out that 3x plus 4. And left behind is the garbage in the front, that 2x, and this time minus 5. And we have to make sure they're in parentheses. And there's our answers. Now, this is a good segue for us to learn how to factor by grouping. So our first one, when we're going to learn how to factor by grouping, is we're going to have a polynomial with 4 terms. And the GCF between these 4 terms that I haven't finished writing is 1. So those are our requirements. The first requirement is that it needs 4 terms. If it doesn't have 4 terms, we're not grouping it. The next requirement is that we need a GCF of 1. So, right here in the front we have a 1 times x cubed. That already predetermines for us that 1 is the greatest common factor between all of the constants. I don't care that 2 can go into all these. 2 can't go into 1. So 1 is the greatest common factor for just the numbers. Then let's look at the variables. We have x cubed, smallest degree wins, remember, x squared, x, and no x's in sight. So our GCF is 1. We have 1, 2, 3, 4 terms, and that was completely intentional and you knew it was coming because my direction said factor by grouping. So now we're going to group. The reason why we need 4 terms is because it's kind of like a double date. We're going to group up these 2 together and these 2 together, and we're going to hope for the best. So between the first 2, we're going to try to find their greatest common factor. So, between the first 2 that we grouped together, we're looking for the GCF. Now, we have that 1 constant again, so already we're screwed there. 1 is the GCF for the constants. Now let's look at the variables. We have x cubed, x squared, smallest degree between just these 2. That's all we're looking at. Only focus here is x squared. So, since we have something in common between these 2, we're going to factor it out. And left behind, and really we're kind of pretending nothing else exists. I'm not too sure if this is going to work. Let me see if I can, there we go. Okay, don't even look at this other piece here. It doesn't exist. We're not thinking about it. All we're concerned is with these 2. They're in their own little world. So, I'm factoring out an x squared. Left behind, well, 1x, because x squared times x gets us x cubed. And now we have minus x squared times 2 will get us 2x squared. We don't need any more x's because we already have the x squared. So that's it for there. Now, Pretend that side doesn't exist anymore. We don't even want to look at it. It's not there. Our only concern is these last two over here. So we got a plus sign in between them. So we're going to bring down a plus. This is kind of crucial. We'll talk more about the next problem where it's a little uglier. And between these two, their GCF is going to be 6. And we can pull it out. So we'll factor out a positive 6, right? Because of that plus sign. And positive 6 times x gets us positive 6x. Positive 6 times negative 2 gets us negative 12. And now you might be seeing the magic. Oops, let me get rid of that. I don't want this. Oh, I can't move it now? Alright. Ah, I got it. Delete it. I don't know what that is. Delete. I'm so sorry. I should probably redo this, but we're just going to keep rolling with it. So now we have a new GCF. We have x squared repeated again. So we'll factor it out. And left behind is the garbage in the front. And we have x squared plus 6. And you are done. This is one of the nicer problems because we had a positive in between the two. I'm going to show you one more with the few minutes I have left on this video. And it's going to have a negative. So we have x cubed plus 5x squared minus 10x minus 50. And now, same deal, 4 terms. The GCF is 1, I'll tell you that in advance. We're going to group the first 2 together and the last 2 together. And we got to be careful. Because there's a negative here in this second group, that means we're going to have to factor out a negative. So, the GCF between the first 2 is x squared, because the smallest degree wins, and the leading number here was a 1, and that makes it automatically 1 for the constants. So x squared pops out. Left behind is an x plus 5. And if you FOIL, you'll see it. X squared times x is x cubed. X squared times 5 is 5x squared. Now here comes our trickier part, that minus. That means I'm going to have to factor out a minus because of that. And the GCF between here, if you want to, you could call it negative 10. Or you could just call it 10. I really don't like thinking about negatives when I see GCFs. That's my preference. I'm not too sure if, if future professors think differently. But I know my GCF for sure is 10 between the two numbers. And I'm factoring out a negative 10 because of that negative there. I don't like it. So left behind, negative 10 times x will get us negative 10x. A negative 10 times a positive 5 will get us negative 50. And it has to be positive because a negative times a positive is a negative. And also it has to be a positive because this was our goal. When we factor by grouping, we want that thing in the parentheses to be the same. If it's not the same, then we screwed up. So that's like our nice little kind of double check in between our steps. So we'll factor out that new GCF. Left behind is the garbage in the front. And there is our final answer. And that looked ugly. Sorry about that parenthesis. And that's all for now.